Uh, Hello, welcome back. So, welcome to grade 9 mathematics session. And I hope you all understood everything that I taught you all in the chapter 1. So, today we are moving on to chapter 2. So, chapter 2 is basically binary systems. So, binary numbers, it's how you convert decimal numbers to binary and how to read binary numbers. So I'm assuming that you all have covered these sections in schools and also maybe in classes. So this is going to be like a recap session, and I hope it will help you all to answer exam questions, and it will be easy for you all to understand the concepts as well. So without further ado, let's move on. Yes, as I said, the the chapter is binary numbers. So starting with, so as you all may know, how the number systems are called. So you all might know the Roman numbers: 1, 2, 3, 4, 5, 6. Just like that, the number is like 1, 2, 3, 4, 5, 6. So these are Roman numbers, and these number system is Hindu and Arabic number system. That's the number system which is accepted by the world and is using right now pretty much everywhere. So considering these are normal decimal numbers, uh, uh, and that's how we consider it in this chapter and as well as in the world. So we are breaking down how we put the numbers in abacuses and how we record it. So there's an example here. I will be using my own example with different numbers. So these ones you might be able to read and understand, but uh, read and understand. So I'll be using my own abacus example. Uh, so here they have used 3725. I'll be using a number like 4246, maybe. Yes. So this number 6 is just going to be the power 10 to the power 0. So these are stuff that you all should know, and I will explain it a bit again. So 1 to the power 0, 2 to the power 0, any number, 9 to the power 0, 121 to the power 0, x to the power 0. Everything is equal to 1. 1. Anything, any number to the power 0 will always be equal to 1. That's something that you should know, and something to keep in your mind. Then moving on, so there are 6 in 10 to the power 0, so it's like 1, 2, 3, 4, 5, 6. Then here this is 10 to the power 0, and this is 10 to the power 1. So 10 to the power 1 means, what is 10 to the power 1 is 10. So this number 4 represents it's, so if you don't regard this 4 and 2, this is just 46. When 46, it's 10 to the power 1 is 10, and 40 is a multiple of 10. So how many tens are there in 46? It's got 1, 2, 3, 4. I hope you'll understand. Then this 2. 2 is 246. That is 10 to the power 2. 10 to the power 2 is about 100. And this 200 is in the section of the hundreds. So 4246. So there are two hundreds, 1 and 2. That is 10 to the power 2. This is 10 to the power 3. This is 4,000. So 10 to the power 3 is 1000. So this is thousands till it goes to 10,000. Then 1, 2, 3, 4. Okay. 10 to the power 3, 10 to the power 2, 10 to the power 1, 10 to the power 0. This is what they have displayed here. So with my own example, that's what I did. Yes. Moving on. So you can see here the example they have taken is 3,725. The example I took was 4,246. So we can write the same thing in this thing in the same way. 4,246. You can write 4 into 1000 plus 2 into 100 plus 4 into 10 plus 6 into 1. Total is 4,246. Simple as that. I've done another example here, which is pretty much the same, so I'm not going to do that again. Then we are moving into expressing numbers in binary number system. This may be a new part for you all. I'm not sure if you all have covered this in grade 8. So let's see. So binary, word by means 2. So when it comes to binary, the base is 2. In other everything that we did, base is 10. That's why you put 10 to the power 1, 10 to the power 0, 10 to the power 1, 10 to the power 2. That is fine. So we won't be needing that part here now. Now everything goes in 2 to the powers, because 2 is going to be the unit system. So 2 to the power 0, 2 to the power 1, 2 to the power 2. So that's what 2 to the power 1 is 1. Just as I said, anything to the power, 2 to the power 0 is 1. Anything to the power 0 is always 1. 2 to the power 2, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16. So this is how the powers of number 2 goes. So you all might have an understanding how the number system works. So then we can see as an example, you can pretty much write any number. So here number 13 they have written 8 plus 4 plus 1. So 2 to the power 3 plus 2 to the power 2 plus 2 to the power 0, 1. So again they have written it this way. 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 to the power 0. It's pretty simple. If we take number, let's take an example like maybe 17. You can write it in different ways. So 16 already is what? 2 to the power 4. Or let's just write 17 is 16 plus 1. Let's say 2 to the power 4 plus 2 to the power 0. Again, if you want 1 into 2 to the power 4 plus 1 into 2 to the power 0 is 17. Simple. Okay. Now this is the part how we consider, how we write, how we convert it to, and how we display it in the abacus for binary numbers. So same. So binary and decimal, what is the difference? So you can see decimal, you have 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But decimal, that is, there are 10 numbers. How many numbers are there in binary? 2. What are the two numbers in binary? It's 0 and 1. These are the two numbers. So when it comes to binary, you will be able to represent any number in those two binary numbers. So if I may explain, if you take any decimal number, 50, 75, 63, any random number, no matter how big the number is, you will be able to put it to binary numbers, which will be definitely unique. So what I'm saying is, if you consider decimal number 67 and 75, are those equal? No. Just like that, when you convert 65, I'm sure the numbers I took, if I said 65 and 75, they are not same in decimals. Just like that, if you convert 65 to binary and 75 to decimal binary, those binary numbers will also never be the same. So there are no two binary numbers which will represent the same decimal number or otherwise. So any number we will have to know how we convert any decimal number to a binary and any binary number to decimal. That is what we are going to discuss in this chapter. So here you can see that they have given a number 11101. So let's take a different number. So anyway, whatever the number we take, we have to make sure that it is written in 1 and 0. So I would say 10110. It's different, right? Yes. So what does this mean? So if this is the number, there is nothing we can put it here. So this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So here there is nothing. There is 0. When it's 1, there is 1. When there is 1, there is 1. Here nothing. And here is this. So what do you think that this number represents? So 2 to the power 1 is 2. 2 to the power 2 is 4. 3 to the power 3, it doesn't matter here. 2 to the power 4, what is 2 to the power 4? 16. 16. So this number represents 16 plus 4 plus 2 is what? 22. So this is the decimal number. This 22 is the decimal number of the binary number 10110. And we always write, if you write a number, we have to put here number 2, like 10112 here 2 or 10110. That's how we write it. That's what we give an idea that we have put it in a notation of binary. So if we just put it in as a number like 10110, so somebody could just put it here, say 10,100. That's definitely not what we want. That's definitely not something we want. So moving on. There's a bit of a technical issue. There's a problem with my mouse. I hope it's not going to be a problem. Yes, same. That is exactly what they have chosen here. So they have given the number 20 and how you convert it to decimal. So that 20 you can write as, there's a small problem with my mouse. So 20, if you get the number 20, so 20 you can write as 16 plus 4. 16 is what? 2 to the power 4. This is 2 to the power 2. So it's 2 to the power 4 is what? So there are no 2 to the power 3 is 2 to the power 1. So 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. So here is 1, 0 1 0 0, and that is what they have displayed here. If I put a random number, let's say 27, so how do you write 27? We can write 27, yes, 27 we can write as 2 to the power 4. Yeah, let's write it normally. 27. So 16, because we can't get 2 to the power 5 because it's 32. 16 plus, we can say 8, which is another. 16 plus is 24, plus 1 plus 1 plus 1. So here we can say 2 to the power 4 plus 2 to the power 3 plus 3 into 2 to the power 0. Yes, I hope you understood how we have written it. So this I will show you all how you specifically convert a number. So I am moving on to that part. So just bear with me. If you didn't understand this part, just bear with me. Don't make it a problem. I will clarify your doubts. If you have any doubts in the past, just leave a comment in the YouTube video in the comment section, and I will definitely look onto it and reply to you all. So this is how you convert a proper decimal number, a proper decimal number to binary. So this is something that you all should be able to do. You should be able to do a basic division. So you all do basic division like this if you are dividing it by 2, but this is a bit of a different way. So you are dividing 27 by 2. Okay, 27 by 2. So we are considering this. So 27 is it divisible by 2? No, it is not. So what is the closest number which is not exceeding 27, which is properly divisible by 2, which is a whole number? That is 26. 26 divided by 2 is 13. Did you understand? So I'm considering this 27 divided by 2 is 13. I'm going to divide 13 by 2. Is 13 properly divisible? No. 12 is divisible, then 6. Then is 6 divisible by 2? Yes. Properly divisible? Yes. Number 3. Then you divide it by 2. You can't divide 3 by 2. What is the closest number? Is number 2. Number 2 divided by 2 is 1. So here, this is what we consider. 27 divided by 2, is there a remainder? Yes, 1. 13, yes, there's a remainder. 6, there is no remainder. 3, there is 1. So we write the number 1, 1, 0, 1, 1. You will understand. Yes, sorry for that. So again, if we consider this number, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. 2 to the power 1 is 1. 2 to the power 2 is what? 2 to, sorry, 2 to the power 0 is 1, 2 to the power 1 is 2, plus 0, plus 2 to the power 3 is 8, plus 2 to the power 4 is 16. So 16 plus 8 is 24, 24 plus 2 is 26, plus 1 is 27. Did you understand? I will do a few more sums. You don't have to worry. So this is basically, so this is how they are teaching how you are writing the number and how you write in the remainders. So these are some basic things that you all should know. So I will do the exercise itself, then you all will be able to understand. So question number A, this one. So 4. So they are asking convert the decimal numbers to binary. Divided by 2. Is it divisible? Yes. Properly divisible, number 2. Is there a remainder? No. Is 2 divisible by 2? Yes. Is there a remainder? No. What is number 2? So then it's 1, 0, 0. Make sure you always write this number first, this second, and this third. This is first, second, and third. That is how you properly write it. Then that is how you get the number 100. Let's do something like D, because it's no point doing each and every sum. You should be able to try some also. I'll do E, which is going to be a bit, I say it's a bit messy maybe. 29 divided by 2. Is 29 properly divisible by 2? No. What is the closest number which does not exceed 29? So we always have to consider a number lower. අඩු අංකයක් අඩු සංඛ්‍යාවක් තමයි අපි අනිවාර්යෙන් බලන්න ඕනේ. මොකද අපිට වැඩියෙන් එකක් අනුමාන කරන්න බෑ. ඊට අඩුවෙන් එකක් තමයි ගන්න ඕනේ. මොකද රිමේන්ඩර් එකක් කියන්නේ ඉතුරු අංකයක් තියෙන්න පුළුවන්. يعني ඉතුරු වෙන්න පුළුවන් ගාන. ඒකින්ද අපිට අනිවාර්යෙන් ඊට වඩා අඩු අංකයක් තමයි තියෙන අංක 29 නම් 29ට අඩු අංකයක් තමයි තෝරගන්න. 29ට අඩු ළඟම අංකය මොකද්ද? 28. 28 දෙකෙන් බෙදුවම කීයද? 14යි. එතකොට රිමේන්ඩර් එකක් තියෙනවද? ඔව්. 14 දෙකෙන් බෙදුවම කීයද? 7යි. 14 දෙකෙන් බෙදද්දි ඉතුරුවක් රිමේන්ඩර් එකක් නැහැනේ. බිඳුවයි. 7 අපි බෙදනවා දෙකෙන්. 7 බෙදන්න පුළුවන් දෙකෙන් බෑ. රිමේන්ඩර් එකක් තියෙනවා. 6 බෙදුවම එන්නේ 7ට අඩු අංකය 6. 6 බෙදුවම එන්නේ 3. මේක දෙකෙන් බෙදන්න පුළුවන්ද? බෑ. රිමේන්ඩර් එකක් තියෙනවද? ඔව් රිමේන්ඩර් එක තිබුණ අංකේ මේක දෙකෙන් 3ට අඩු අංකය 2. දෙකට මේ දෙක දෙකෙන් බෙදුවම එන්නේ 1. රිමේන්ඩර් එකක් නැහැ. හරිද? 3 කියන්නේ 2නේ. එතකොට රිමේන්ඩර් එකක් නැහැ. එතකොට අපි ගන්න ඕනේ මෙතන 1 බිංදුව 1 1 බිංදුව 1. දැන් මම ඔයගොල්ලන්ට කියන්නේ I'm just telling you all to check whether this answer is correct. So you should get 29 when you convert this back to decimal. So how are you going to convert this back to decimal? So 2 to the power 0 is 1. I'm going to go a bit fast. 1. 2 to the power 1 is 2. It doesn't make a point. 2 to the power, this is 4. This is 8. This is 16. 1. I'm sorry, there is not going to be a 0 here. We don't consider that. We don't consider that. So what you're getting is 1 1 1 0 1. My apologies. 1 1 1 0 1. So 2 to the power 0 is 1. 2 to the power 1 is 2. It doesn't matter here. 2 to the power 3 is 4. 2 to the power 4 is 16. 2 to the power 5 is I miss number 8. This is 8, 60. So 1 plus 4 plus 8 plus 16 is 24, 25, 26, 27, 28, and 29. number 29. That's how you get it. There is no remainder here to put it as a 0. That's a part that I included, then which is wrong. So I will do another sum and say show that if you all got it confused. Let me erase this. Considering a number like let's say question number I, number 97. 97 divided by 2. Let's consider 96 because 97 is not divisible by 2. 96. 96 is 40. 40 48. 48 into 2 is 96. So you write 48. Is there remainder? Yes. You divide 48 by 2 is going to be no remainder. It's going to be 24. You divide 24, no remainder, 12. You divide it by 2, 0, no remainder, 6. You divide it by 2, no remainder, 3. You divide it by 2, there is a remainder, is 1. So answer is 1, 1, 0, 0, 0, 0. How many zeros? 4 zeros. So let's see if this adds up properly. So 2 to the power 0 is 1. 2 to the power 1 is 2. It doesn't matter. 2 to the power 1 is 2, it doesn't matter. 2 to the power 2 is 4, it doesn't matter. 2 to the power 3 is 8, it doesn't matter. 2 to the power 4 is 16, it doesn't matter. 2 to the power 5 is 32, it does matter. Then 2 to the power 6 is 64. So 64 plus 32 plus 1 is 6, 7, 97. So even when I said that it doesn't matter, it's always, as I will show you, always write it as that you all have considered it. So as because I was going it fast, that's why I displayed it like that. So if you all can write, so the one we got was 1, 1, 0, 0, 0, 0, 1. So here always try 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and 2 to the power 6. So write this as this is 64, this is 32, 16, 8, 4, 2, 1. And write the addition as, because these numbers are not there, write it as 64, 32 plus 0 plus 0 plus 0 plus 0 plus 1. This total is 97. You all won't have to do this. I'm actually covering the next part itself. This is to check whether your answer is correct. I myself, if I have extra time, I would definitely do this to check whether my answers are correct. So then this is exactly the part 2, which they give and to check whether and calculate binary numbers to then decimals. So here let's do this one. I'm picking at random h and the last one also. Yeah, so it will be easy for you. So question number B is 1 1 0 1, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. 2 to the power 1, this is 2, this is 4, this is 8. This doesn't matter. So 8 plus 4 is 12, 12 plus 1 is, this is 13. This is 13. Going to H. If you couldn't take it, take note. Just post the YouTube video and you will be able to check it out. Then this number 1 1 1 1 2 3. Yes, H. So this 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. So it doesn't matter, doesn't matter, doesn't matter. 2 to the power 3 is 8. This is 16. This is 32. So yes. So you will have to add 32 plus 16 plus 8 is 56. Answer is 56. Let's do the last one as well. Question number J. 1 1 0 0 0 1 2 is 2. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. I'm going to do it a bit big because it might get a bit confusing. 1 0 0 0 1 to the base 2. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 4, 2 to the power 5. So this is 1. Doesn't matter. These ones is 2, 4. You all should know now. 2. This is 2, 4, 8, 16 plus 32. So so the answer is here. You can see 32 plus 16 plus 1 is 49. Answer is 49. So yes, we have covered that also. Now you all have a good idea about abacuses right now, since I covered that part. So yeah, just basically going into the addition. So any number. So this is talking about addition. So they have shown this 101 plus 10 is equal to 111. The reason is this. So there's only two numbers in binary. It's 1 and 0. So when it comes to 1 and 0, 1 and 0, if there is a 1, you should put 1. If there are two ones, then it will consider as 0. So with this, how many ones are there? 1. So now the number 1 is the powerful one here. So you put it as 1. So from 0 and 1, 1. And from 1, 1. We will do a bit of a difficult one. 1 1 0 1 0 1 plus 1 1 1 0 and a 1. Bit of difficult one. So here there's 1 1. There's 1 here. So there are two ones. What do you do here? When there are two ones, you put 0 and you carry 1 here. Is it clear? So when there are two ones, you put a 0 and you take the 1 to the other side. So there's a 1 here. 1 plus 1 again, what happens? Again 0 and you carry that 1 here. Then there's another one. 1 plus 1 plus 1. What do? Then you put a 1 and you put the other from 1 to 3. You put 1 here and the other 2 as another 1 here. There's another 1 here. Then there are 2. There's another small one that we brought. 1 plus 1 is again 0 and there's extra 1, you put it here. This might have been a bit confusing. I will go to a bit of difficult ones again. So I think you will be able to figure it out. So okay, they have given examples. So let's see. Let's do the same ones. 1 1 1 0 1 1 0 1 1. At 1 plus 1 is 0, you can take it to 1 here, you put it 1 plus 1 is 0, you put 1 here. 1 2 3, you put 1 here, you take 2 to the other side as 1. and that 1 plus 1 is again 0, and you then question number 2, 1 1 1 0 1 1 1 1. Here 1 0 1 0 1. Go a bit fast. I hope you all understood. If they have done it, so you can see exactly how they bring it. So you all didn't see this part before, so now you all can see the same answer that I got is here, and that is how we do it. So exercise number of exercise 2.3. So I'll do this. Now see, 1 is 0. You carry a 1 here. 1 plus 1 is 0. Again you carry a 1 here. 1 plus 1 is 0. Again, apologies because I'm writing it too close. The numbers are getting a bit messed up. 1 plus 1 is 0 and 1 here. 1 plus 1 is again 0 and 1 here. 1 plus 1 is again 0 and 1 here. 1 1 1. There are 3 ones. So you put 1 here and you bring another one down here. 1 plus 1 is 0. You put a 1. So the answer is, if it's not clear, 1 0 1 0 0 0. Then if you add it from the side, it's exactly the same thing. J, they have put it to the side. So let's do this. Let's consider this. I always prefer to do it in vertical way, so you might not mess it up. But this one, let's do it in, okay, this one will do vertically, will do vertically, and this one will do in the normal way. So G, if you write G, 1 1 1 1 1 1 1 1 1. So it comes in pairs. If there are 2 ones, it's going to be a 0. If there are 3 ones, it's going to be 1, and another one is carried out. If there is 4 ones, there's going to be a 0 and 2 to be carried out to the next one. I hope you all understand. Let's see. 1 1 1 is 1, and you put 1 here. So there are 1 2 3 4 ones. So you put 0 and you carry 2 to the other side. So 2 plus 1 is again 4. You put a 0 and you put 2 to the other side. Is 3 means 1, and you carry 1 to the other side is this. I hope you understood it. So now we are going to do the H, question number H. Previously I did question number G, if you didn't know. Yes, question number H. So let's see. 0 0 0 is going to be, state rate is going to be 0. 1 1 1 is going to be 1, and there's going to be a 1 remainder. That we take 1 2 3 4, 0 and a 2 remain. 2 plus 1 is 3 4, again and 2 remain. We take this 2 plus 1 is 3, is 1, and there's a 1 remainder. That one you take is the answer for H. So here you will have to check. Okay, this is getting a bit tricky. You'll have to fill in the blanks, and you should have a good idea what you're doing. So for this to be a 0, this should definitely be a 1. 1 plus 1 is 0, and you take 1 to the other side. So if you take 1 to this side, and there's 1 1, there's definitely going to be a 0 and 1 here. For this to be 0, there should definitely be a 1 here. 1 plus 1 is 0, and you take 1 here. Then 1 plus 1 is 0 and a 0. 1. So I think this is clear for you all. This is, if it's not clear, 1 0 0 0 0 is the answer here. If it's not clear inside the boxes, I will zoom it a bit, then might be a bit convenient, is it? I could have done this before. Sorry. Yes. So let's do E also. For this to be 0, this definitely should be a 1. So when you put 0, there's 1 here. For 1 1 and this to be 0, this should be a 0 definitely. Then there's 1 carried over to this side as well. 1 plus 1 is 0, there should be 0 here. Then you take 1 here, and this is going to be 0. I'll do f as well. 1 and 0 is going to be 1 definitely. For this to be 1, this should be a 0. 1 1 is 0, and there's a 1 carried out, and it's 1. Then you take the other one here, and it will display as 6. 1 0 1 1 1 0 0 0 0. Same thing goes with subtraction. Same thing goes with subtraction. I'll do with the examples and show you all. So here, 1 and 0, 1, you subtract 1 from 1 is 0. Then you can't subtract 0. So you take this here, and it will be like 2. And there's no value here. 2 minus 1 is 1. This is the answer. 1 0. Let's do this. 1 minus 0 is 0. And for this is like normal subtraction. So when I put it here, this is going to be a 2. Then from this 2, you keep 1 and you give, this is be 2 2 2. Yes, so we will be moving on to yeah, we were discussing this. Yes, so again from the beginning, so 1 minus 1 is definitely 0. So from here there's nothing to subtract, so we will have to bring from this side. So here when it comes here, this is going to be 2. So this is going to be 0. And here when you bring it here, you're going to have 2 here. From here 2, here 2. So when I say when you get 2 here, you will send, you know what, I'm going to draw it in bigger scale, so it's going to be easy for you to understand. So the same question I'm going to draw as 1 1 0 0 0 1 1 1 1. Okay, so 1 minus 1 is 0. Here you don't have anything to subtract. So from here, when you give this 1 to here, it will be 2. So you will have to give 1 to here as well. From this 2, you will give 1 here. So the remaining will be 1. So here, when you give 1 to this 0, this will become 2 again. And from this 2, you are giving 1 here. So here it will be 1, and here it will be 2. So 2 minus 1 is going to be 1. 1 minus 1 is going to be 0. Here there is 0. So 0 minus 1 is 1. This might be a bit confusing. The theory part that you will have to remember is to do this type of calculations is that when you take 1 from a future, from a higher number to towards the back end, it will consider it as a 2. Just like when we put 1 and 1, you put it 0 and you put 1 here, just like that. You take this 1 back, it will be considered as 2. I hope it's clear to you all. If you all have any questions, just drop a comment on the video, so I will clarify it for you all. So let's consider question number K. Again, I'm gonna write it in big letters. Zoom it again. Big letters. So 1 1 0 0 0 minus 1 1 1 1. Can you subtract 0? No. So we will have to bring this. When you bring, there's going to be 2 here. From 2, you have to give one of the 2 here. One of the 2 දෙකෙන් එකක් මේකට දෙනවා. දෙකෙන් එකක් ගියා මෙතන ඉතුරු වෙන්නේ එකයි. එතකොට මෙතන තියෙනවනේ දැන් දෙකක්. මෙතන ඉතුරු වෙන්නේ එකක්. මෙතන තියෙන දෙකෙන් එකක් දෙන්න ඕනේ මෙතෙන්ට. එතකොට මෙතන ඉතුරු වෙන්නේත් එකයි. ඒ දෙන එක මෙතෙන්ට ගියාම ඒක දෙකක් වෙනවා. එතකොට දෙකෙන් එකක් අඩු කරාම එකයි. So you subtract 1 from 2 is 1. You subtract 1 from 1 is 0. 1 from 1 is 0. And there is again 0 here. මෙතන බිඳුවයි. මොකද ඒ එක තමයි දීලා තියෙන්නේ හැපැත්තට. So you give 1 from here to this. And මෙතන වෙනවා දෙකක්. දෙකෙන් එකක් අඩු කරාම එකයි. This is the answer for question number K. To further clarify doubts, I will do question number H as well. 1 0 0 0 1 1 1 1 1 minus 1 is 0. Here, no. Give 1. This will be 2. From 2, you have to give 1. So here it will be remaining is 1. So here they will have 2, and when you give 2, 1 of the 2, දෙකෙන් එකක් මෙතන දුන්නා මෙතන දෙක වෙනවා. මෙතන එකයි ඉතුරු වෙන්නේ. දෙකෙන් එකක් අඩු කරාම එකයි, එකෙන් එකක් අඩු කරාම බිඳුවයි. මෙතන එකක් තියෙනවා අඩු කරන්න එකක් නැහැ එකයි. Oh, I did not see this. Have I made the same sum? H is the one I did here also, no? Okay. Let's do I. Let's do I. The number is here. 1 0 1 0 1 0. Subtracting 1 0 0 1. Never mind. So from here you can't. You give this 1 to here. This will become 2. Subtract 1 from 2 is 1. Here this will be 0. 0 plus 0 minus 0 0. Here you give 2. 2 minus 1 is 1. 0 0. Here you give 2. 2 minus 1 is 1. Simple. Answer this. And yes, there's another exercise. So find the value. So these you will be able to. I'll do the C for once. 1 1 0 to 1 1. And here is 0 0 1 1 1 1 0. If I'm correct, yes. There's nothing 1. If you subtract 0 from 1, it's going to be 1. 1 is going to be 0. So you are subtracting 2 from here. So when you give 1 from here, this will be 2. But when you give 1 from A, තියෙන දෙකෙන් එකක් මේ පැත්තට දුන්නාම මෙතන ඉතුරු වෙන්නේ එකයි. මෙතන තියෙනවා දෙකක්. දෙකෙන් දෙක අඩු කරාම බිඳුවයි. මෙතන එකෙන් එක අඩු කරාම එතනත් බිඳුවයි. මේ එක තියෙනවා. So when you do these type of sums, question number B, first you should know that BODMAS, if first we have division. B, first you have to solve brackets, then divisions, then multiplications, then additions and subtractions. So brackets, divisions, multiplication, addition, and subtraction. So here there's a bracket. So first solve the bracket here, then do the subtraction. Then the remainder is what you do in the subtraction. I hope it's clear. So this one you should be able to know how to put this as a binary number. So after the next number, now write the next number after adding 1 to each given number. So you should be able to do. It's pretty simple to do all this. It's very easy. Represent this. You should know that 4 to the power 2 is what? 4 into 4 is 16. 16 is 2 to the power 2 is 2, 4, 2 to the power 3 is 8, 2 to the power 4 is 16. So what is the binary number? So you know 16 divided by 2 is 8. Now remainder 4 is again 0, again 2, 1 is 1, 0, 0, 0, 0. This is the answer. Then simplify. This is a simplify. This is pretty very easy. Just subtract it and convert it to binary. Very easy. It's one of the easiest questions you all can actually get. Then convert 39 into binary, 39, 49, 30 into binary, and find the differences. See whether the answer you obtain is the same as exactly. Then summary. Binary number system, the fundamental digits are 0 and 1. That is a very important thing that you have to remember. Everything, every note, every binary numbers will be represented by digits 0 and 1. This is very important. This is very important. The places values in binary number systems are, yes, this is something that you all should know. So always start taking 2 to the power 0, 2 to the power 1, 2 to the power 2, power 3. It's continuous. It's pretty much it. So that brings us to the end of chapter 2, binary numbers. Done. I hope everything was clear to you all. So I might have skipped questions because it's just recurring questions, and I did the difficult questions for you all, and I think it was helpful. So if you all have any questions, feel free to comment on our YouTube channel in my video in the comment section. If you have anything, I'd be more than happy to clarify all those doubts. And so we will meet again in another chapter. And till that, do all the exercise sums that they have asked you all. And if you have any doubts, just as I said, you can comment. And see you guys next time.